Good morning. Questions are related to further differentiation. The diagram shows a metal plate containing a rectangle with sides x centimeter and y centimeter and a quarter circle of radius x centimeter. The perimeter of the plate is 60 centimeter. Question 1. Express y in terms of x. So here the main concept is the perimeter of the plate, which is 60 centimeter. Now, how do you find the perimeter of this plate? So this plate consists of a rectangle and a quarter circle. So perimeter of the plate is perimeter of rectangle plus perimeter of a quarter circle. Okay, you can identify the figure. How do you find the perimeter? You know, perimeter is the total length. Okay, so what is perimeter of rectangle and that of a quarter circle? So as it is mentioned, the perimeter of the plate is 60 centimeter. You can split it as perimeter of a rectangle plus perimeter of a quarter circle, which is 2 of x plus y plus 1/4 of 2 pi x, which is equal to 60 centimeter. And we know that the perimeter of a rectangle and circumference of a circle. Perimeter of a rectangle is 2 of L plus B, where L is the length and B is the breadth. And circumference of a circle is 2 pi r. So the circumference of quarter circle, perimeter of quarter circle is 1/4 of 2 pi r, which is pi r divided by 2, where r is equal to x. So when you simplify this question, 2x plus 2y plus pi x by 2, pi x by 2 is equal to 60, which is 60 centimeter. So our task is to make y as the subject to the formula. So firstly we'll take pi x by 2 the right hand side. We get 2x plus 2y is equal to 60 minus pi x divided by 2. Now transpose 2x to right side, we get 2y is equal to 60 minus pi x by 2 minus 2x, so that y is equal to, so how do you get y here? Divide both sides by 2 or transpose 2 to right side. So we get 30 minus pi x by 4 minus x as a result. The next question is, show that the area of the plate is A is equal to 30x minus x square. So this question dealt with area, you know, which is area of rectangle plus area of quarter circle. So recall the concept of area of rectangle, which is length into breadth, and area of quarter circle is pi r square by 4, because area of a circle is pi r square. So let's deal with the second question, question B. Area of the plate is area of rectangle plus area of quarter circle, which is equal to xy, because L into B, xy plus pi x square divided by 4, which is equal to x of, we know the value of y from question A, which is 30 minus pi x by 4 minus x. So replace it, 30 minus pi x by 4 minus x plus pi x squared by 4. Simplify it, we get 30x, x to be multiplied to each and every term of the bracket. That means expand the bracket, we get 30x minus pi x squared by 4 minus x squared plus pi x squared by 4. Now check whether we can cancel any of the terms. Yes, minus pi x squared by 4 plus pi x squared by 4 can be cancelled. So the resultant answer will be a is equal to 30x minus x squared. Hence shown. And the next question is, given that x can vary, find the value of x at which a is stationary. X varies. That means there is a change in x. So stationary values can be found by dA by dx is equal to 0. The derivative is 0 with respect to x because x varies here. So let's find the derivative of a. And we know if a is stationary, then dA by dx is equal to 0. As per the question, they mentioned a is stationary. So we get dA by dx is equal to, let's find dA by dx of the given equation, 30 of 1 minus x square, that is 2x, which is equal to 30 minus 2x, and as per our question that is equal to 0. So from this find the value of x. We get minus 2x is equal to minus 30, x is equal to minus 30 divided by minus 2, that is equal to 15. So the value of x is 15. And the last question is, find the stationary value of a and determine whether it is maximum or minimum value. We have to determine whether a is that critical value is maximum value or minimum value. So here we have two methods. One is with first differentiation and the other with the second differentiation. I'll show you both. So with first differentiation, already we got the value of x as 15. Now let's take a number line, whether 15 is a point, and take the side below 15 and above 15. That means take a point from below 15 and one from above 15. So let me take the points 0 and 20, 2 points. Now substitute x is equal to 0 in the derivative dA by dx. We get the result as a positive one, which is 30. 30 minus 2 times 0. That is a positive result. Yes. And when x is equal to 20, we get dA by dx as 30 minus 2 times 20, that is minus 10. Which is negative. So 0 gives us positive result and 15 is 0 and 20 is a negative result. So the graph will be like this, increasing, stationary and decreasing. That makes the stationary point maximum. Or if you find the answer with the second derivative, which is d square a by dx square. Find d square a by dx square, that is the second method. We get that is as minus 2. Directly we get the answer which is smaller than 0. That means second derivative is smaller than 0. So remember the concept, as it is smaller than 0, the point is maximum. So when the point is minimum, when it is greater than 0. Okay. Second question. A point is moving along the curve y is equal to 2x plus 5 by x in such a way that the x coordinate is increasing at a constant rate of 0.02 units per second. Find the rate of change of the y coordinate when x is equal to 1. So here the equation of the curve is y is equal to 2x plus 5 by x, and there is a change of x coordinate with respect to time. So what is the change? 0.02, which can be mentioned as dx by dt is equal to 0.02. Okay, now we required the rate of change of y coordinate with respect to time. That means we need the answer of dy by dt by using chain rule. So find the derivative of y, which is dy by dx is equal to 2 of 1 plus 5 of minus 1 x raised to minus 1, which is minus 2. Because when you write y in standard form, we get y is equal to 2x plus 5x raised to minus 1. And when you find the derivative of x raised to minus 1, we get it as minus 1 x raised to minus 2, which implies dy by dx is equal to 2 minus 5x raised to minus 2. Okay, that is the derivative of y. Now when x is equal to 1, they have mentioned x as 1. So when x is equal to 1, what happens to dy by dx? When x is equal to 1, dy by dx is equal to 2 minus 5, 1 raised to minus 2. You know 1 raised to any power is 1. So we get the result as 2 minus 5, which is minus 3. Now we can find the rate of change of y with respect to time, which is dy by dt is equal to, use the chain rule, dy divided by dx multiplied by dx by dt, which is equal to, you know, dy by dx is minus 3 multiplied by dx by dt given in the question, which is 0.02. So we get the answer as minus 0.06. That means rate of change is negative. Third question, the curve with the equation y is equal to x cube minus 2x square plus 5x passes through the origin. Show that the curve has no stationary point. So we have to show the curve has no stationary point. So our equation of the curve is y is equal to x cube minus 2x square plus 5x. So when it has no stationary point, let's find it. So find the derivative of y, which is 3x squared minus 4x plus 5. To check whether it has stationary points, let's make use of the nature of roots. And you know, nature of the roots is based on the term known as discriminant, which is b square minus 4ac. So let's find b square minus 4ac, which is minus 4 the whole square minus 4 into 3 into 5, which is equal to 16 minus 60, which is a negative answer. That means b square minus 4ac is less than 0. So recall it. If b square minus 4ac is less than 0, it has imaginary roots. That means roots are not real. That means we don't get any real value for x. So the curve has no real stationary points. Hence, we can conclude that it has no stationary points. Okay, so the second part is denoting the gradient of the curve by m. Find the stationary value of m and determine its nature. So here the gradient is denoted by m. Now we have to find the stationary value of m. So gradient, gradient is same as dy by dx. That means here it is denoted as dy by dx is equal to m. That is m is equal to dy by dx, which is equal to, what is dy by dx as per the previous question? It is 3x squared minus 4x plus 5. Now we have to find the stationary value of m. Means we have to find the derivative of m with respect to x. Because stationary value is always with derivative is equal to 0. So to find the stationary value, what we have to do? Yes, we have to find the derivative of m. Means differentiate m with respect to x. So find out dm by dx. That's our task. Why? Because stationary value gives us the conclusion that dm by dx is equal to 0. So it implies, let's find dm by dx. Dm divided by dx is equal to 6x minus 4. Yes, recall the concept of differentiation, and as per the question, dm by dx is equal to 0 because it is a stationary point. So we get x is equal to, find out the value of x here. That means 6x is equal to 4, or x is equal to 4 divided by 6, which is equal to 2 out of 3, 2 over 3 as answer. Next task is to find the value of m. For that, substitute x in the equation of m. We get 3 of 2 by 3 the whole square minus 4 of 2 by 3 plus 5. Just go on simplification, we get it as m is equal to 11 by 3. That's the value of m. Now to find the nature of m, that means to find the nature of stationary point, we have to make use of the second derivative, which is d square m by dx squared. So when you find the derivative of dm by dx, once again we get it as a positive answer. D square m by dx square is greater than 0. That means the point is minimum. Question 3 consists of a prism. The diagram shows an open container constructed out of 200 centimeter square of cardboard. The two vertical pieces are isosceles triangles with sides 5x centimeter, 5x centimeter and 8x centimeter. And the two sides pieces are rectangles of length y centimeter and width 5x centimeter as shown. The open top is a horizontal rectangle. So we have a open container which is made up of cardboard, and to make it, the area used is 200 centimeter square. So when we made it into a container, the area of cardboard is same as the surface area of the container. And here the container can be called as a prism. Why? Because it has two congruent bases, which are two isosceles triangles. So here what we need to make use of is the area of cardboard is 200 centimeter square, which is same as the area of surface area of the container, and the container has two isosceles triangles and two rectangular faces because the third face is opened. So area of cardboard is same as area of two isosceles triangles plus area of two rectangles. Okay, now let us find the area of isosceles triangles. So for that, draw a line which is perpendicular to the base from the vertex, which divides the base into two parts of units 4x centimeter and 4x centimeter. Now we need the perpendicular height. For that, let us make use of that shaded right triangle, which has the hypotenuse 5x centimeter and the base 4x centimeter. So by Pythagoras theorem, Pythagoras theorem is the square of hypotenuse is equal to the sum of the squares of other two sides. So we get the perpendicular height h square is equal to 5x squared minus 4x squared, which makes h is equal to square root of 25x squared minus 16x squared, that is equal to 3x. So the perpendicular height is 3x. Okay. Now we can find the area of isosceles triangle. Area of a triangle is half base into height. So we get half into base is 8x multiplied by height is 3x, which is equal to 12x squared. So we have two isosceles triangles with areas 12x square centimeter square each. Now our next task is to find the area of each rectangle. It is very simple. Our rectangle has dimensions y centimeter and 5x centimeter. So area of each rectangle is length into breadth, which is equal to y into 5x, that is 5xy. So the surface area of container can be found by area of container is equal to area of two triangles plus area of two rectangles. That is 2 times area of triangle we already found as 12x squared. So it is 2 times 12x squared plus 2 times area of rectangle is 5xy, which is equal to 24x squared plus 10xy. But we know that area of container is 200 centimeter square. So which is equal to 200. That implies 10xy is equal to 200 minus 24x squared. It implies y is equal to transpose 10x to right side. We get 200 minus 24x squared divided by 10x is the first answer, hence shown. The second part is show that the volume V centimeter cube the container is given by V is equal to 240x minus 28.8 x cube. So here remember the concept of volume of prism, which is base area multiplied by height. We already found the base area as the base is an isosceles triangle. Base area is 12x squared multiplied by height. Height is y. So we get 12x squared multiplied by y, already we found as 200 minus 24 x squared divided by 10x. We have to simplify it. We get x and x get cancelled. We get 12x of 20 minus 2.4 x squared. That means we can divide both of the terms by 10. So which is equal to 240 minus 28.8. 12 into 24. 12 into 2.4. 28.8 x cube as volume. Hence shown. Now the next question is, given that x can vary, find the value of x for which v has a stationary value. Similar to the previous question, as v has a stationary value, the derivative of v is equal to 0. So here the variance is x. So derivative of v with respect to x is equal to 240 minus 28.8 multiplied by 3x squared. Derivative of x cube is 3x squared, which implies dy by dx is equal to 240 minus 28.8 times 3 is 86.4 x squared, which is equal to 0, as v has a stationary point. So from this find the value of x squared as 240 divided by 86.4, which is x squared is equal to 240 by 86.4, or x is equal to square root of 240 by 86.4, which implies x is equal to plus 1.67. Now determine whether it is a maximum or minimum stationary value. So to find out whether it is maximum or minimum value, let us calculate the second derivative of v with respect to x. That is d square v by dx square is equal to minus 86.4 into 2x. That is equal to minus 172.8 x. When you replace the value of x is equal to 1.67 here, d square v by dx square becomes a negative value. It will be a negative value. Into 1.67, that will be less than 0. So I am leaving you the negative part of x that you find out.